Hello, welcome back. It's time to talk about measuring technique uncertainty. The first uncertainty was measuring equipment uncertainty, and that's talking about how precise our equipment is. This is talking about how precise we are when we use the equipment, and it's slightly different. So what we're working on here is we measured how long it takes some sort of pendulum to swing one period, right? So we have a pendulum swinging back and forth, and we're measuring how long it takes it to go one to the other. And we're using different, and we're changing things, and we're using different measuring instruments. One of the major measuring instruments we used was a stopwatch. And when we talk about the stopwatch's precision or its equipment uncertainty, we just talked about how good the stopwatch itself was. But we really didn't get a chance to discuss how good we are using the stopwatch. Like when we press the stopwatch with our thumb, are we really that quick as we think we are? Is that included in the stopwatch's precision? It's not. So we also have to include ourselves and how we're using the equipment in our discussion of errors and uncertainty. And that's what this one is all about. So I'm going to shrink down and we'll discuss a little bit of this. The first thing is I have some bad news in that I want you to read this yourself and answer these 3 questions in your lab records. In fact, why not just do it now? So go ahead and pause the video, read over these paragraphs, and answer those 3 questions, and then unpause and we'll talk about the next step. Fantastic. If you are having a really hard time with any of those 3 questions, please do reach out to your professor. We are happy to help answer any of your questions one-on-one. All right, so the next thing we're working on here is actually measuring your technique uncertainty. And to do this, what we're going to do is figure out the standard deviation if you make 10 identical measurements in a row. So we're going to get a graph something like this, but with a few less measurements. We're only going to take 10. A lot of times when you're getting standard deviation, it's really useful to get 100, 1,000, a million different measurements. But if I made you take a million measurements, you would kill me. So we're going to do just 10. And actually, it's pretty good. Pretty good. So I'm going to make myself big again, and we'll talk about how we're going to do this. All right. What you're going to need for the next part of the lab is actually your pendulum. Don't panic if you threw it away. Go ahead at this time and find materials that are as similar as you can get to your original pendulum, and then unpause me when you've got all that together. All right, now we just need one pendulum. I have a pendulum here that I used one time. It was rocks tied to a string, okay? Again, if your pendulum for today is a little different than the pendulum you used the first set, it's okay because we're actually measuring how you interact with it, not as much how it is. Okay, so the next thing you want to do is actually tie your pendulum to the original place that you had it tied to if you still have access to that place. If you don't, then you need to do your best. Mine was tied to my light source here, but my light source is busy because it's kind of dark today. It's busy lighting me and the pendulum up. So I need to find something else to tie this to, okay? I don't have anything that's camera available. So don't do what I do. I'm going to just hold it with my hands. Again, if you just hold it with your hands, you're not going to get good data. The only reason I'm doing this is because I need to be somewhere on camera and I didn't have a ring stand at my house. So what you're going to do is actually tie this to wherever you had it originally. You'll thank yourself anyway because you really having 2 hands for this is better than just one. Okay, and then what you're going to do, so pretend this up here is where you had it hanging. Okay, so build a pendulum that's a medium length. For me, this is a good length. And then what you're going to do is find its period 10 times in a row without changing the length, without changing any of the other variables that you were keeping constant that time. So for me, I'm not going to change, what was I doing? Silly things like color. I'm not going to change the color. I'm not going to change the smell, you know. Okay, a lot of people though, let's see, they were changing the mass and the angle that the pendulum was swinging at, and the length and some other things. So just go ahead and keep those the same every single time. Okay, so when I did this, I measured 5 swings. So I would measure it like, let it get started, and then say go. 1, 2, 3, 4, stop. So that would be one measurement, and I'd write that number down. Then I just do it again. Go. 1, 2, 3, 4, stop. That was measurement number 2. I write that down. I do it again. Go. 1, 2, 3, 4, 5. That's measurement number 3. And I do that 10 times. So 10 of the exact same thing in a row. So I will write down 10 measurements with the same length, angle, and thing. It's going to be boring, but I'm going to write down 10 measurements in a row. Okay? Then I want to make sure that they're the time for just one period. So what I'm going to do is open up Excel, which I forgot to open up before my video, so I apologize for the 10 extra seconds that this is going to take. Uh-oh, it's going to make me shrink down. Okay, shrinking down, blank workbook. Okay, I'm going to make Excel nice and big so we can watch together what I'm doing. All right, and then I'm going to enter in, so let's say I got 10, 9.9, 8.9, 9.5, 11, 11.2, 10.7, 5. Okay, so those are my 10 different measurements. And then what I want to do is divide all of those by 5 periods to make sure that they are now the time for one period. Okay, to do this, I'm going to do equals 1 divided by 5. So I'm going to use Excel. What I did was I entered in equals A1 divided by 5. So I'm using my Excel skills. If you're not sure exactly what I just did, so you can go ahead and divide all those numbers in your calculator. So now I have a column of times that was one period. Next, what I'm going to do is highlight that column. And then in another empty box, I'm going to type in, and this is following the instructions that I have over here, the lab instructions. Let me shrink this down so you can see what I'm talking about. I'm on this step here. So I'm going to type in equals and then STDEV. And then I'm going, oh, oops, I highlighted too early. Then I highlight my numbers and then close and then press enter, and there's my standard deviation. So what I would enter into my lab records then is wherever it says standard deviation, I'm going to enter in 0.1609. I'm going to keep it to 4 significant figures, and then the units on all those measurements were seconds. So I'm also going to put the units of seconds there. Your standard deviation units matches the units of what your times were, and my times were in seconds. All right, that is how we are going to calculate our measurement technique uncertainty. So thank you very much for joining me, and we're on to the next step.